All right, so apparently my iPad decided to stop. So we're going to start over again with activity 3. Once again, we are looking at these two figures, and we're working with a parallelogram right now. So to find the area of that figure, we multiply the base times the height. Okay, now we're up to 3 times, so we're going to take 3 times 2, that's going to give us 6. So 15 times 6 gives us 90. Well, this we multiplied times 3 to get here. We multiplied this times 3 to get here. What did we multiply this by to get here? We multiplied it by 9. The scale factor was 3. Isn't 3 squared 9? Slide that over a little bit. Okay, so that's where the scale factor was greater than 1. The item got bigger. Well, now let's talk about what happens. Does the same thing happen when the copy is smaller? So if we take half of 5, we can just say 5 halves here. This is going to have 1 because 1 half times 2, and we multiply those together to find the area, we get 5 halves. So we're looking at 10, we're 1 half. How do we get from there to there? Or we could think of it as 2.5. So what did this get divided by? 1/4, or 0.25. And isn't 1/4 1 half squared? Yes. Okay. Let's try 1/3 now. 1/3 of 5. 1/3 times 5 is 5/3. 1/3 of 2 is 2/3. So that gives us 10/9. Oh, didn't that get multiplied by 1/9? And isn't 1/9 equal to 1/3 squared? Parentheses around that. It is. So our results ended up doing the same thing as it did with the other thing. Now let's try the triangle. I'm just going to make a real quick another table just like the one up above it, and we're going to do the other figure and see what we notice. Okay, so we have the scale factor, the base, the height, and the area. Okay, and the original figure, let's pull this over, is a triangle. And remember, to find the area of a triangle, we take 1 half the base times the height. Okay, so the base of this triangle is 4. The height of this triangle is 5. And the area is going to be 4 times 5, which is 20, times 1 half, which is 10. Okay, then we're going to do with a scale factor of 2. So 2 times 4 is 8. 2 times 5 is 10. 8 times 10 is 80. Times 1 half is 40. Oh, are you seeing a pattern? Okay, scale factor of 3. 3 times 4 is 12. 3 times 5 is 15. Let's see. 12 times 15 times 1 half is 90. Oh, I'm definitely seeing a pattern. We'll squeeze in 1 half right here. Half of 4 is 2. Half of 5 is 2.5. Nope, I did that wrong. Yeah, that's right. 2 times 2.5 is 5, and half of that is 2.5. Okay. And last but not least, 1/3. 1/3 of 4 is 4/3. 1/3 of 5 is 5/3. 5/3 times 4/3 is 20/9 times 1/2 is 10/9. Oh, does this chart look exactly like that chart? It sure does. Okay, so compare your results with the group that worked with a different figure. What is the same about the answers? Well, did we end up with the same areas? Yes, we did. Okay, we used the same scale factor. What is different? Well, the bases and the heights were different. Okay, so the dimensions were different, but we ended up with the same area with the same scale factor. And we have discovered as well that it has been multiplied by the scale factor squared. Okay, so if you drew copies of those figures using a scale factor of 5, what would you expect it to be? Well, remember, we're going to take the original area, which was 10, multiply it by the scale factor squared. So we would expect the area to be 250. What if we took 3/5? Well, the original area was 10, multiply it by 3/5 squared. That's going to give us, let's see, 10/1 times 9/25. That gives us 90/25, which equals approximately 3.6 if I was to put it in the calculator. Okay, so in summary, scaling affects lengths and area differently. When you make a scale copy, all the original lengths and distances are multiplied by the scale factor. If we make a copy of the rectangle with the side lengths of 4 and 2 using a scale factor of 3, we end up with a rectangle that is a 6/12. Well, let's look at the area. The area of this is 2 times 4, so the area of this is 8. The area of this is 6 times 12, so the area of this figure is 72. So the area of this is 9 times bigger. Okay, so the area of this, and 9 times bigger is 3 squared times bigger, which is what the scale factor was. So the scale factor squared. Slide that over so you can see it. All right. And the reason for that is, if you look at this, we have made it 9 times bigger, 3 by 3 bigger. So let's think about what we've got. When we take the side, any length, we multiply it by the scale factor. This is the original. Multiply it by the scale factor, that's going to give us the copy length. If we take the perimeter, the original perimeter, I'm going to abbreviate here, original perimeter, we will multiply it by the scale factor, and that will equal the copy perimeter. But if we take the original area, we have to multiply it by the scale factor squared, and that will give us the copy area. And remember, the angles, do they get multiplied by the scale factor? No, the angles are congruent. So the corresponding angles stay the same. Didn't leave myself enough room there. Corresponding angles are congruent. They never get multiplied because that would change the shape. All right, so I hope you understand that. do some practice problems, and I hope you grew your math brain. See you on Zoom.